Good morning, afternoon, or evening, depending on where you are. Thank you for joining us today. Welcome to the second of three BIM 360 webinars for construction. My name is John Harridge with Autodesk, and I will be the host and moderator for today's session entitled How to Integrate BIM 360 Glue in Undergraduate Construction Management Classes. A little bit about myself. In my role as a technical marketing manager, I create learning experiences to inspire the next generation of designers, engineers, and builders to create a better world through the future of making things. Today, I'm delighted to be joined by our guest speaker, Dr. Zhang Wu from the Milwaukee School of Engineering, who will formally introduce himself a little later on this presentation. With that, let's take a look at the agenda for today's presentation. So I'll begin with describing the era of connection and associated technology solutions, and then move into our featured case study, and then wrap up with learning resources, next steps, and questions and answers. If you are new to BIM 360 or have already begun a trial of BIM 360 and looking for new ideas for applications inside the classroom, you have come to the right place. Just to recap, in the first webinar, we introduced the BIM 360 family of cloud-based collaboration solutions for construction through a graduate level construction management BIM course with the University of Florida. In this webinar, we will focus on model-based collaboration and coordination using BIM 360 Glue through the lens of undergraduate courses with the Milwaukee School of Engineering. So over the next decade, we are seeing technology trends that will radically disrupt how we design, build, and operate buildings. Let's discover how the power of the cloud can not only transform industry, but academia as well. Before starting the presentation in earnest, I would like to take a few moments to review some housekeeping items on the use of GoToWebinar. Please note that for the entire duration of this presentation, all attendees will be in listen-only mode. To close the control panel, click the arrow button indicated by Mark 1 in the user interface panel. To confirm audio settings, review the audio panel indicated by Mark 2. If voice over the internet is not working for you, you can obviously switch over to a landline connection. To submit questions during the presentation, enter your question in the bottom field of the questions pane indicated by Mark 3 and hit the send button. Just to let you know that today's presentation is being recorded and will be uploaded within 3 business days for playback. With housekeeping out of the way, let's begin. So I'll start off with the era of connection. So as our society becomes more connected with mobile technology, providing for anytime, anywhere access, it seems like almost anything is possible in the era of connection. In the context of building projects, we are calling this connected BIM. And Autodesk is at the intersection of this growing demand for more buildings and infrastructure and the democratization of technology. So connected BIM is building information modeling plus the power of the cloud. It's a cloud-enabled, intelligent, model-based process that unites the design, build, and operate segments. Connected BIM makes possible anytime, anywhere collaboration. In addition, it also provides for data continuity across the lifecycle of a project and provides deep insight into improving decision-making. So now let's take a look at some of the connected BIM solutions. Supporting our connected BIM idea on the cloud side is our Autodesk BIM 360 platform. BIM 360 is a platform of services designed to accelerate project delivery and to help minimize risk across the project team. BIM 360 provides a shared cloud-based database of project information that makes the database easily accessible to all stakeholders at any time from anywhere, connecting all the project teams across AEC. Here you see a listing of BIM 360 solutions and how they fit into the design and construction phases. So just note that the entire BIM 360 family is cloud-based, providing team members with access to these services through either a desktop or mobile device. Autodesk is making these solutions available to institutions for free, and I will cover those details at the end of this presentation. Now let's take a closer look at some of the BIM 360 tools that are featured in today's presentation. So BIM 360 Glue is a cloud-based BIM management and collaboration product that connects your entire multidisciplinary team and streamlines BIM project workflows in one location from pre-construction through construction execution. With virtually anywhere, anytime access to the most recent project models and data throughout the project life cycle, BIM 360 Glue helps you review projects and resolve coordination issues faster while advancing the construction layout process. So now I'd like to reintroduce to you Dr. Zhang Wu of the Milwaukee School of Engineering to share out their story on the integration of connected BIM solutions in their curriculum program. So Dr. Wu, the floor is yours.
Good morning, afternoon, or evening, depending on where you are. My name is Zhang Wu, Program Director of Construction Management at Milwaukee School of Engineering. First and foremost, thanks everyone so much for choosing to attend this webinar today, especially when there are so many things going on during the summer. For the next hour, we are going to look into the details of how we implement the concept of connected BIM and use the BIM 360 Glue and other VDC technologies at Milwaukee School of Engineering. Hopefully, you find this webinar very informative for you. Let me talk a little bit about MSOE. So MSOE is a private university founded in 1903. According to US News and World Report, MSOE is 10th best undergraduate engineering program in the United States among the universities with no doctorate programs. MSOE has about 2,500 students, 140 full-time faculty members at 6 departments, offering 20 bachelor's and 9 master's degrees. At MSOE, we have several different CM programs, but among those programs, some of the unique programs include 5-year Bachelor's of Science Construction Management and Architectural Engineering degrees. In this program, the students seek CM and one of the AE specialties, such as structural engineering, electrical building systems, or mechanical building systems. The last bullet point shows another unique program, which is an MBA in Construction Management, which is designed for working professionals who has more than 5 years of working experience in the construction industry. Let me quickly go over the learning objectives of today's webinar. So it will describe the benefits of a BIM 360 Glue for design review, clash detection, and issue tracking. We learn how to integrate BIM 360 Glue into various CM course settings. This webinar will explain the benefit of using BIM 360 Glue for assessing ACCE and ABAT student learning outcomes. And we will identify the learning resources available for developing your own implementation strategies. Some of the key agendas for today. We will talk a little bit about BIM and VDC education at MSOE. VDC stands for Virtual Design and Construction. This agenda will lead to specific discussion on tangible benefits of using connected BIM for CM students and educators, BIM and VDC pedagogical strategies, and a list of CM courses using BIM and VDC technologies at MSOE. Then we will introduce 2 specific courses as case studies employing BIM 360 Glue at MSOE. These case studies will give you detailed explanations on coursework, team project, student activities, and assessment data collection. As a wrap-up of the case studies, we will finish up by discussing lessons learned and recommendations for integration. Let's talk about BIM and VDC education at Milwaukee School of Engineering. First of all, why connected BIM? Here are some tangible benefits of using connected BIM for our students. The use of connected BIM helps the students demonstrate current industry project and collaboration workflows. Currently, there are a lot of construction companies using cloud-based applications to work with the extended project team members. It is basically the fundamental concept of connected BIM, and we can incorporate this concept into a classroom environment. We can develop effective communication and soft skills required in the real world. Communication and soft skills are highly prioritized student learning outcome at most of the CM programs. The way the students interact and communicate in BIM 360 Glue helps the students develop effective communication skills aligned with the workflow in the real world. They can learn how to use the latest VDC technologies. The industry is changing so fast, and it is important to keep up with the current BIM and VDC technologies available out there. It is just because they have to use a few of them as soon as they started their job on day one. Here are some tangible benefits for educators. We can make classes up to date. Incorporating the concept of connected BIM can update your class and effectively cover some of the key learning objectives, such as related to communication, technology, and project management. 5-10 years ago, most computer technologies in the construction industry were desktop solutions, and the use of cloud-based solutions helps educators bring in real-world applications into classroom. Since the concept of connected BIM is about transparent communication and data sharing, most cloud-based solutions provide a way to review the work history of the team members, so the educators can gain insight into students' thought process by looking into the student activities on the cloud. Since the most of student work is accessible in the cloud, the educators can easily collect program assessment data as needed. Here are key strategies of BIM and VDC education at MSOE. BIM education is not only about technologies, but also about how to work together with extended construction project team members. First and foremost, we use BIM and VDC to help the students understand data flow across the project lifecycle. At MSOE, we spend a significant amount of time to discuss how construction data and information are shared among the project stakeholders. By doing so, the student can understand the project lifecycle process and the roles and responsibilities of the project stakeholders, such as the owner, designer, builder, users, and other parties associated with the project. We integrate a few BIM and VDC software in the AE, Architecture Engineering, CM, and Civil Engineering curricula in order for the students to experience the current technologies available out there. We incorporate multidisciplinary elements in BIM education because BIM and VDC improves teamwork and collaboration. We try to add diverse student groups with a different educational, technical, or ethnic background. And also we invite industry partners such as mentors, guest speakers, critics, or advisors. They are typically virtual construction managers or VDC managers who can testimony what is going on in the industry in terms of BIM and VDC. It enhances the student educational experience by exposing students to real-world life experience from someone who has been using BIM and VDC technologies on a daily basis. BIM education is a component of an integrated team approach, so the student can learn about how to make relationships and respect the team members, and how to effectively work as a team and having trust, effective communication and information sharing, and learn about the work ethics in the team setting. Lastly, digital construction site is a place where critical project information is generated during the construction phase. The students need to know how to handle the information by using connected BIM technologies. Here are the CM courses using BIM and VDC technologies at MSOE. As you see in the table, there are 7 different CM courses that use BIM VDC technologies to achieve the course learning objectives. There are many other classes using BIM as a supplemental teaching tool. All of these courses including hands-on exercises during the lab hours so the students can experience how to use the technologies. Another key feature of the BIM class is the use of team project, applying the concepts of connected BIM. Today, we will feature 2 courses, AE 2001 Advanced BIM and CM 4321 Construction Project Management 2 as our case studies. These classes are chosen because many of the CM programs already have similar courses so that you can easily use anything from today's webinar to revise your course or implement your own strategies. So first case study is about AE 2001 Advanced BIM for sophomore year students. AE 2001 Advanced BIM is being offered to sophomore students majoring in AE, CM, and civil engineering. And this is an undergraduate level course focused on the utilization and management of BIM and VDC technologies. During the 11-week quarter period, the students need to attend 3-hour class every week and roughly spend 3 out-of-class hours per week to complete coursework and team project. This is the second BIM course following the freshman seminar, so the students taking the course already have the fundamental Revit skills, such as placing basic architectural elements or organizing drawing sets. Advanced Revit skills are demonstrated, and BIM 360 Glue is introduced to demonstrate the concept of connected BIM. This course focuses on modeling assignments and integration project. 7 Revit modeling assignments covering model authoring skills on architectural, structural, and MEP systems are given to the student. And the students start from a PDF drawing set of one of the MSOE buildings. They are also asked to create Revit models as they visualize the building components from the PDF drawings. Once completing the individual Revit assignment, the students work on an integration project with a team to develop a federated BIM model by applying the concept of cloud-based collaboration. At this time, the students need to perform as one of the designers or engineers. Here are a little more details on the classwork and group project of AE 2001. Both classwork and group projects are focused on level 200 BIM development, which means the model element is graphically represented as a generic system, object, or assembly with approximate quantities, size, shape, location, and orientation. During the class period, the students focus on building advanced Revit skills to create one of the MSOE buildings using Revit. Each individual create Revit models of their own discipline. The group project focuses on connected BIM process, so the students work as a team assembled of diverse education background, and they use a BIM 360 Glue for model coordination and clash detection. And also they have to write a report on team collaboration, technology, and process. Here are 3 course learning objectives, and we will discuss how these course learning objectives are measured in relations to the student learning outcomes of ACCE, which stands for American Council of Construction Education, and ABAD, Accreditation Board of Engineering Technology Accreditation Standard. Let's take a look at some of the key student activities in AE 2001. The first, project ramp up. After completing the individual Revit assignment, the students start their team projects as they watch tutorial videos on BIM 360 Glue and install BIM 360 Glue desktop on their personal laptops and upload headshots and team pictures on the team's BIM 360 Glue site. After the team's BIM 360 Glue site is ready, each student needs to upload Revit models on Glue. They can easily do it in Revit. As you can see, it is just a three-step process. First, they just click Add-ins tab, and then Glue button under BIM 360 pane. Then simply they select the project host, then just simply follow the instructions to upload their Revit models. After uploading their 3D models, Glue provides several ways for the team members to collaborate. As you can see, the user interface of Glue is very simple. First, the team members can check the work history of the team members on the right side pane. And then the team members can upload individual models. This can be done by architects, structural engineers, or MEP engineers. Our students take one of these roles. And they merge models together. With these merged models, they can check for clashes, create markups, and send notices for issue tracking. This is a typical model navigation screen in BIM 360 Glue. As you see, the model navigation tools are the same as other Autodesk software, so the students can easily learn how to use the BIM 360 Glue. There are three sets of tools, including command bar, navigation bar, and navigation steering wheel. This is a screenshot of a merged model area. In this view, students can create views and notify via email. And students can create markups and notify via email for issue tracking. And they can create new clash reports and view existing clashes from clash section. Running clash detection is so easy and simple in BIM 360 Glue. First, they just simply click clash detection button on the command bar and select two sets of objects or models to compare. The students can save clash images and export clashes as image files. Finally, they can develop a clash detection report. Since this is the first time of running clash detection for the sophomore student, the focus is on learning how to run clash detection tests in BIM 360 Glue. We encourage you to discuss how to mitigate clashes through to resolution, but it is a kind of a embarrassing, intimidating task for the sophomore students. The students were informed they will have a chance to develop a method for evaluating clash result in context of a severity in senior year. This is how we align course learning objectives and ACCE and ABET student learning outcomes. As I mentioned in a previous slide, the use of the BIM 360 Glue helps you collect necessary assessment data for your accreditation purpose. Since most student activities are recorded on the cloud, though we were able to collect data such as notification emails and simply copies of BIM 360 Glue site to be used for the program assessment purpose. And the students were also capture their work examples in the project report called BIM Quality Control Report. For example, we use a specific section of the report called Participation, Teamwork, Collaboration as data of ABET SLOD and ACCE SLO student learning outcome number 9, which directly show how the student work effectively in a team environment. Here are some lessons learned. The modeling assignment can be minimized if necessary. If your program has CM students only, you do not have to include extensive modeling assignments. We just did it at MSOE because the class has 3 different majors, including architectural engineering, construction management, and civil engineering students. Provide a PDF drawing set of one of the campus buildings. It was easy to get the drawing sets from the facilities office, but also it is a good exercise of a plan reading practice. And also students can understand the difference between paper-based and BIM-based process. However, PDF to Revit process could be time-consuming. Assemble multidisciplinary teams. Select the students who could be a good team member is important because some of them are really technologically inclined. Some students taking more time to learn the technologies, and then it depends on their leadership skills. And it is important to know their majors and other technical backgrounds so you can distribute the student members evenly. Here are some recommendations. Learning curve on Glue is very short. So if you have a list of video tutorials, the students can easily learn it outside of class, so you can minimize the tutorial hours in class. And also you can use learning resources developed by Autodesk, which is really giving you the clear direction of the technology tutorial. Build teamwork first, then models. So I encourage some activities such as having a meal together or hanging out together, and then they can work together and build models. Provide clear requirements on hardware and software. Some students don't know how to manage the computer storage space or don't remember the Autodesk ID and password, so they can access to the BIM 360. Make sure that your students maintain their laptops and software licensing requirements on track. Area for improvement. It is important to find a simple project example. In my classes, we use MSOE buildings. Some of the buildings are unnecessarily too complicated, so students took so much time to build the Revit model. If you want to minimize the modeling assignment, you can always find a simple project samples, and you can consider student work and consider student majors. Develop their own BIM execution plan. So all of the team members need to agree on very specific individual responsibilities, such as uploading specific model elements or reviewing design issues. Otherwise, students tend to be in a hurry in the last minute, and it decreases the project quality. So here, I want to take a look at case study number 2, which is a project management 2 class, CM4321. So CM4321 is offered in winter quarter of the senior year. So it is a perfect time to implement multidisciplinary course where the students can bring in knowledge and skills from the previous courses. This course gives 5 VDC assignments to the individual student. These are focused on developing fundamental skills of VDC tools, such as 3D site logistics, 4D scheduling, or 5D estimate. And the team project is given to the student teams, which is composed of 4 to 5 students. They need to develop a pre-construction proposal providing professional solutions for real project. The goal of the team project is to leverage the information extracted from BIM to deliver high-quality proposal within a limited time frame. Each student spent roughly 2 out-of-class hours to complete given assignments and team project. Here's a little more detail about the course structure. Both classwork and group projects are focusing on the use of VDC technologies for construction management. Classwork focuses on learning VDC technologies, and the federated Revit model is given as a starting point. Group project is focused on connected BIM process to produce professional pre-construction solutions. The course aims to demonstrate all of these stages of connected BIM. The image on the right side represents 3 images, 3 stages of connected BIM integration. So first stage is cloud-based model coordination. Second stage is a cloud-based file sharing and model management. And the third stage is collaborative BIM, which is the best case scenario of using connected BIM. It happens when all of the BIM and VDC technologies are seamlessly integrated to optimize the workflow and teamwork. Here is the list of BIM and VDC assignment. The students start with reviewing and merging given Revit models in BIM 360 Glue. The instructor reviewed a sample project, received a sample project from a local contractor, and continue on clash detection and 3D site logistics plan and 4D scheduling and 5D BIM-based estimating. All of the deliverables are assembled as a team report called pre-construction proposal. We did not spend much time on the tutorials for 4D scheduling or 5D estimating because they had a chance to work on the fundamental skills in previous courses. For example, our scheduling class have a couple of hours of special lectures on 4D scheduling at the end of the quarter, so they can taste how to do the 4D scheduling using the schedules they developed in the class. Here are 5 student learning objectives of Project Management 2. And for the first 3 bullet points, the first 3 learning objectives are related to the connected BIM coursework. Again, we will see how the objectives will be linked to ACCE or ABAT accreditation standard. Here are some of the key student activities. First, issue tracking by using markups and notifications. After uploading and merging the given Revit models, the students were asked to review and share some issues from the current Revit models by using markup and notification tools in BIM 360 Glue. So for issue tracking, students were required to use all channels of communication, including face-to-face meetings, virtual communication tools in BIM 360 Glue. All right, so next, the students were also asked to do clash detection in Navisworks using the models on BIM 360 Glue so that they understand the concept of interoperability and cloud-based collaboration. So simply, they can open BIM 360 Glue model from Navisworks by just clicking BIM 360 tab in Navisworks, and then select the project and select the merged model, and then they can run clash detection in Navisworks. They open the clash detection tool, and then simply they implement run clash detection test in Navisworks. Also, the students perform the data integration to share a model coordinated glue with the BIM 360 field project. The process is simple as well. So after selecting items for issue tracking or equipment sets in Glue, you can simply click Shared with a Field button. Once the model is shared, BIM 360 field users can map the shared model in field. Okay, as I mentioned, this course includes the 5 learning objectives, and each of the learning objectives are well aligned with the student learning outcomes of ABAT and ACCE. The first 3 course learning objectives are specifically related to the student learning outcomes of ABAT and ACCE, and the instructors were able to collect data from the term project report or work examples from BIM 360 Glue. Here are some lessons learned from this course. So it is important to give the students enough time to go through the tutorials because each student has a different learning pace. Develop multidisciplinary team setting by including the students with a different educational, technical, or ethnic background is important so that students know how to work with the different types of people. It is important for the students to develop BIM execution plan. Basically, it describes teamwork, participation, and collaboration. And then you can make sure that they can work together throughout the entire quarter as indicated in the BIM execution plan. We encourage both virtual and face-to-face interaction approaches so that they can use all channels of communication to work faster and more efficient way. Provide the best practices related to connected BIM. We used weekly guest speakers who brought in a lot of topics centered on connected BIM, which make the student really motivated to learn about it. Areas for improvement. We could not include in-the-field experience to help make the connected BIM more real. It would be great if we can develop BIM 360 glue and field exercises that require the students to do something on the construction job site. That would be an excellent addition to this course. We realized that students were struggling when they were asked to develop practical solutions for the clashes. By virtue of using BIM 360 glue, it was easy for the students to detect clashes, but they could not come up with the effective solutions. For example, the students were good at detecting and resolving hard clashes across the systems, but they did not think about another potential clashes if they moved that specific object. This is why it is important to discuss 3 different types of the clashes, including hard clashes, soft clashes with clearances, and the time-based clashes across system. So as a wrap-up, I'm going to give you a few points of a lesson learned. So overall, what worked well is incorporating multidisciplinary elements. You can do this by many different ways, by setting up cross-listed courses to bring the students from different majors, such as mechanical engineering or electrical engineering, so that those students also interested in the building industry as well. And invite the mentor for each team, or invite guest speakers, receive sample projects from, with the real stories, and then you can always work with your own industry advisory committee members. Also, integrate BIM-related software. So we can use a lot of different learning resources, which is from Autodesk, or you can find a lot of YouTube videos on connected BIM and your software. Some of the key takeaways. So most CM programs teach project management course in junior or senior year, and it typically includes a lot of topics. It is a perfect setting to teach separate teaching subjects in a multidisciplinary teaching and learning environment. Connected BIM gives a great experience for the students to understand a data flow across the project lifecycle so that they can understand the true meaning of working together and integrated team approach. Here are a couple of areas for improvement. Teach and practice integrated team approach. So we provide a lot of different materials, but it was challenging to teach and practice that in a classroom setting because they have a minimal experience in team teaching or team learning experience. It is recommended to use some of the articles or lectures on teamwork and collaboration, formally teach relationship, trust, and respect, and also other dimensions of teamwork, such as trust, communication, information sharing, and work ethics. More detailed BIM execution plan will be great help. So it will design an execution plan process fits everyone's busy class schedule, help the students understand the individual roles and responsibility, and provide a goal for measuring the progress throughout the project. Here are some recommendations for integration. Consider individual differences on technology learning. So we can do this by minimizing in-class tutorials on technologies. Provide clear expectations on teamwork and collaboration. It is important to provide your students with clear expectations to make the teamwork more smoothly going on. If you decide to use a team project, Please consider the amount of work considering the number of team members. Use lean principles for efficient team workflow. The students tend to rush at the last minute, and the work quality would be significantly lower when they don't spend enough time. So it is important to keep up with the coordinated weekly work plan so that they can measure the progress every week. If you can, use peer evaluations to check individuals' team performance. The instructors also use the peer evaluation scores toward the final grade. That will be the awesome way for the students to understand that how important to work with the team members. Also help students utilize the knowledge and skills obtained from discrete courses in a synergistic project-based environment so that they can be done as a team. Okay, I think that was the end of my case studies. Now, John will lead the presentation to talk about Autodesk Learning Resources.
All right. Thank you, Dr. Wu, for sharing out an amazing case study on the integration of cloud technologies inside the classroom. The strategies that you use to introduce cloud technologies across a variety of courses help students understand the value of having a common data environment through the power of the cloud with BIM 360. So now I'd like to follow up with some learning resources Autodesk can provide to you and your students. So Autodesk is passionate about helping you to inspire, engage, and prepare students for academic and career success. So through our Autodesk education community, students and educators have free access to individual downloads, and institutions have access to network licenses of our Autodesk software. The Autodesk Design Academy community helps educators introduce students to the world of design and construction with free hands-on supplementary projects and course materials that promote critical thinking and problem-solving skills. We've recently added a student-led, self-paced online course format to support the flipped classroom approach. For upper-level students and busy construction professionals, I suggest checking out Autodesk Contact Academy as another resource to be aware of. So here are just a few of the course titles in our Autodesk Design Academy portfolio, and obviously some of these address the topics that were mentioned today. So anything from reality computing through building information modeling to construction management and planning are available to you through that portal. The Student Expert Network is a global program that provides a great opportunity for students to learn, connect, and inspire others to increase their profile for employability. So when they enter the program, they gain access to online learning content that goes above and beyond what's available on Design Academy. And as they escalate through the program, they would gain opportunities for jobs and or summer internships. And towards the upper end of the program, you would have the ability to represent Autodesk at key conferences and events. Next is our certification. So as the technology develops, so does the need for in-depth education regarding software. So Autodesk provides the opportunity for students to validate their skills by taking product certification exams to gain industry-recognized credentials. And we have those exams for Revit, AutoCAD, Civil 3D, and many more titles as well. So technology is continually evolving and improving how work gets done. So we began in the era of documentation. Autodesk was born 35 years ago and helped lead that shift from the drafting table to computer-aided design with our flagship product, AutoCAD, in 1982. And then we moved into the era of optimization, and we introduced building information modeling technologies to accelerate project delivery to visualize, simulate, and analyze building performance before breaking ground. And today, new technologies are disrupting the way things are designed, made, and operated. So Autodesk is building upon our BIM portfolio with cloud-enabled technology and platforms that will help enable new means of designing, building, and operating in the era of connection. So now's the time for students to use the same tools that industry is using to manage projects collaboratively and effectively. Here we're illustrating what those technology roles are in the era of connection. So there is great demand for BIM managers. If you look on the job boards, there's a lot of them that are going unfulfilled because there's not enough qualified talent in the marketplace to fill those roles. And then here we're illustrating the technical competencies that these career roles would require of industry. So just to quickly wrap up, next steps, download the desktop software from our Autodesk education community. Apply for a BIM 360 education subscription from the Autodesk education community. I'll share the details of that in just a moment. Next, download or enroll in curriculum from Autodesk Design Academy, as I mentioned earlier. We are posting administrative and end user guides on Autodesk Design Academy on our Learn page under Take a Webinar. So those will be posted again after today's session. Also, from that same page, you can watch the first webinar in the BIM 360 series. I would encourage you to check that out if you haven't seen that already. And then I would encourage you to download and install the BIM 360 Glue add-in for Revit 2018, so you can take full advantage of that. Now to discuss the education subscription offering. So Autodesk is providing a subscription to BIM 360 to institutions of these 4 BIM 360 solutions. First one being BIM 360 Docs, which delivers a complete connected solution to manage all 2D plans, 3D models, and other project documents. We've already discussed BIM 360 Glue in today's session. BIM 360 Field is field management software for 2D and 3D environments that combines mobile technologies at the point of construction that's cloud-based. And BIM 360 Plan helps you build more reliable project work plans and reduce waste associated with overproduction, excess inventory, and task rework. So it helps support the lean construction processes. So at the link shown in the middle of the screen is where you would go to apply for that subscription. And let me talk about some of the details here. So again, we're offering this opportunity to institutions only. You can either apply at the enterprise level for the entire campus, or if you just want to apply at the individual program level, we're flexible. We can work with you on that as well. The subscription term is for 3 years, and it should be renewable at the end of term. And just to be clear, once Autodesk provides access to these BIM 360 services, it's the responsibility of the institution to manage and distribute these cloud services to students via their email address associated with their Autodesk ID. So with the presentation essentially wrapped up, I would like to open the floor to questions and answers. And so just a reminder, in the question pane, go ahead and type in your answer and hit the submit button. We'll take a look at those and try to get as many of those answered as possible. And while you're gathering your thoughts and giving me some time to scan the question pool, let me start off with a question for Dr. Wu. So Dr. Wu, I'd like to have you expand maybe qualitatively the idea of collaboration effectiveness in terms of how things got done, and how was the connected BIM tools were they serving as an enabler to improve the quality of conversations, problem-solving capabilities, or speed of resolution? Were you able to, noticeably see improvements in those areas?
Oh, of course. I think that the most important benefit of using Connected BIM, which is basically a cloud-based solution, is like you mentioned, anytime, anywhere access to the information, necessary information for project management, which gives a really good foundation for the student to work more effectively. And the cloud-based collaboration tools, Connected BIM, BIM 360 Glue, provide a really good central repository of project data. And then all the functionality is achieved on the cloud. So students don't have to worry about hardware, software issues. So all of these kind of combined into the effectiveness of work process. So students easily understand the value of cloud-based connected BIM for the more effective workflow. And I think that the understanding the concept is basically the really strong competitive edge for the students who will look for the job in the construction industry.
Great. Let me ask another question that might be on people's minds. Can you maybe expand or elaborate on how you're working with industry to advise curriculum or the kinds of interactions that they're having with your students?
Yes. So the industry advisors or mentors or helpers, so they really like to come to the classroom setting and show what they're doing. And so it is really fortunate for me because MSOE is located in downtown Milwaukee, and we have a lot of construction companies around the town, and we can use their help from really big urban scale projects, case studies, to the small residential cases as well. So regardless of their project size and volume, and they are really interested in improving their work process. And we realize that they are using a lot of different spectrum of BIM, VDC technologies, including connected BIM concepts as well. So it is a great real world stories for the students. That's really awesome addition to the class. And then that kind of a connection is also lead to the job site tours and some other personal connections for the job opportunities. So basically, it is a really good aspects of promoting this concept into the class.
Yeah, very good. Just as it relates to the job market side, because your students are getting exposed to these connected BIM solutions, are you noticing that your students are standing out better in the job market? Are they finding jobs more readily because they have these experiences in hand?
Yeah, absolutely. As you know, a lot of students have opportunities for internships before the graduation, and then they already know what kind of technologies are available. But depending on the company's strategies, some small companies just use box folder or Dropbox to share the project drawings and files. And some bigger companies implement advanced connected BIM technologies. So knowing that available technology options, that increase their employability. And then I know that employers really appreciate they are very fluent in technologies, so that they show the different level of kind of potentials for the existing into the existing process. So yeah, generally, yeah, they really appreciate, and I hear that a lot from our industry advisory committee board members.
Okay, super. Let me ask you one question from the audience. They're just saying, thank you for sharing this wealth of information with us. And they were curious to know, do you have any project models that you're willing to share with other schools?
Yes. Yeah, actually, I use the models from our industry supporters, and they are okay with sharing this model and use this model in the classroom. So if you send me an email in the webinar screen, and you can easily write down my email address, woo@msoe.edu. Yeah, I can forward that model. And I have it in the box folder, so I can easily share the box folder link, and you can download the model. Yeah, absolutely. Just contact me.
Fantastic. Thanks for your willingness to do that for our audience. So I did put on the screen how you can reach us, either for Autodesk Education. You could reach us at connected.bim.edu@autodesk.com. Or if you wish to reach out to our presenter today, Dr. Zhang Wu, at wu@msoe.edu. So just as a reminder, today's session is being recorded, and we should get that posted up on Autodesk Design Academy here in about 3 days. You'll also receive a follow-up email from GoToWebinar with the recording link. And let me just kind of wrap this up here. So in summary, you heard through Milwaukee School of Engineering's case study how Autodesk connected BIM solutions transformed the student experience by bringing industry collaboration and coordination workflows into the classroom. So connected BIM means collaboration with impact. So please join us in preparing the next generation of builders. This concludes today's presentation. Have a great day.